There is a place on the moon called the Sea of Rains, and somewhere on that dark plain of frozen lava sits a machine about the size of a small bathtub, standing on 8 wire wheels, with a mirror bolted to its front and angled down toward the earth. It has not moved since the autumn of 1971. Nothing up there buries it and no weather wears it down, so it sits exactly where it stopped, in the open, under a sky that is black at noon, and for almost 40 years, nobody could find it. Every clear night, physicists fire lasers at the moon and read the faint echo off the mirrors we left up there, the ones from the Apollo landings, and one on a second Soviet rover parked elsewhere on the surface. From this one, they got nothing back, which made no sense, because a mirror does not break, it has no power to lose, and it cannot get up and walk away. It was out there, in plain sight, on a world with nowhere to hide, and still the beam went out, year after year, and nothing came home. So how do you lose a machine on the moon and then find it again in a single night? I want to tell you about one of the strangest disappearances in the history of spaceflight, and it comes in 3 parts: the machine and the 5 men in Crimea who drove it across the moon by remote control, the night in 1971 when the signal stopped, and the search that finally found it 40 years later. Stay with me for that last part, because when the physicist who caught the signal first saw what came back, his words were that this could not possibly be it, but it was. Nobody had touched that mirror in 4 decades. No one had been anywhere near it, and once you understand why that should be impossible, you will see this whole story differently. Now, to understand why a lost mirror mattered so much, you have to understand what the machine that carried it actually was. In November of 1970, the Soviet Union landed the first wheeled vehicle ever driven on the surface of another world. Its name was Lunokhod, which means, roughly, moonwalker, and it did not look like anything we would call a rover today. Picture a squat metal tub, a little over 2 meters long, riding on 8 thin wheels, each one turned by its own motor. It weighed around 840 kilograms. On top it carried a hinged, curved lid, and the inside face of that lid was covered in solar cells, so that during the long lunar day, it tipped open to drink in sunlight and charge its batteries. At night, the lid closed over them like a clam. What it did not carry was a driver. Lunokhod was steered from the Earth, in real time, by a team of 5 men sitting in a room in Crimea, and they were doing something hard, harder than it sounds, because a radio signal takes over a second to cross from the Earth to the moon, and over a second to come back. Every command they sent arrived a beat late, and every picture they saw was already a beat old. They were driving a vehicle they could not feel, across ground they could only half see, always steering not for where the rover was, but for where it would be by the time their command caught up with it. Drive too fast and you would pitch it into a crater you had not seen yet. It was almost not there at all. The first attempt to launch a machine like this, in February of 1969, ended when the rocket carrying it broke apart about 50 seconds into the flight. That failure is part of why American astronauts reached the surface first. The second attempt, in November of 1970, worked. A lander called Luna 17 set down on the Sea of Rains, unfolded a pair of ramps, and the rover rolled down onto the dust and began to drive, and it drove far. It was built to last about 3 lunar days, which is roughly 3 Earth months. It lasted 11, crossing more than 10.5 kilometers of the moon over almost a full year. The mirror on its front came from France. It was what physicists call a corner reflector, a cluster of glass faces set at right angles to each other so that any beam of light striking it bounces straight back the way it came, back toward whoever sent it, whatever the exact angle. Bolt one of those to the moon and you have a target you can hit from 250,000 miles away with a laser. Time the round trip of the light, and because the speed of light is fixed and known, you can turn that time into a distance. You can measure how far away the moon is at that instant to within a few centimeters. The Americans had left mirrors like this at 3 of the Apollo landing sites. A second Soviet rover, Lunokhod 2, would later carry a twin of the French reflector. Together, they became the anchor points for one of the longest-running and most precise experiments in modern physics, one that has been measuring the moon for over half a century. It is how we know something that stops me when I say it out loud. The moon is drifting away from the Earth, receding from us by just under 4 centimeters a year, about the rate your fingernails grow, and we have watched it happen for 50 years by bouncing laser light off those mirrors and timing the echo. They are among the most useful objects human beings have ever placed on another world. which is exactly why losing one was such a problem. Here is what happened. On the 14th of September, 1971, the men in Crimea held their last normal session with the rover. Then the lunar night came down, and the temperature outside the little tub fell toward minus 150 degrees. Through every earlier night, the rover had kept its own instruments alive with a small source of radioactive polonium, which gives off heat as it slowly decays. But that source was finite. It had been fading for almost a year, and this time the warmth was not enough. When the sun rose again at the end of September, the rover did not answer. It had gone cold in the dark. On the 4th of October, 1971, the anniversary of Sputnik, the mission was formally declared over. The rover stopped exactly where it stopped. On any ordinary machine, that would be the end of it. But this one had a mirror on the front, and a mirror needs no power and does not age the way electronics age. It will keep bouncing light back for as long as the glass is intact. The rover was dead. The reflector was not. In principle, you could range it, fire a laser at it, and measure the moon for centuries. In principle, because to hit a mirror on the moon with a laser, you have to know almost exactly where it is. This is the part people find hard to believe, and it is worth being plain about. A laser sounds like a perfect, infinitely thin line, but by the time the beam has crossed the gulf to the moon, it has spread to cover a patch of ground kilometers wide, and the light that struggles back is so faint that you are counting individual particles of it, a handful of photons out of the trillions you sent. To pull that whisper out of the noise, you fire in a very narrow window of time, and you point at a very specific spot. Aim even slightly off, and you get nothing. Silence that means either the mirror is broken, or the mirror is not where you think it is. For the American reflectors, and for the second Soviet rover, the positions were known well enough, and physicists ranged them for decades, but the position of Lunokhod 1 had never been pinned down. A few measurements had been taken in the first months after it landed, and then, as far as the open scientific record was concerned, they vanished. They were never properly published. Years later, the study in the journal Icarus that finally located the reflector would describe it, plainly, as lost. The best anyone had was a rough guess, a spot on the Sea of Rains known to within several kilometers, and this is what I keep turning over, the part that nags at me. That mirror was never in danger. It sat in the open the entire time, unbroken, perfectly able to do its one job. We lost it to a filing gap, to a set of coordinates that were taken and then never written down anywhere the rest of the world could use them. A machine that had crossed 10.5 kilometers of another world, misplaced for 40 years because of paperwork. Year after year, the ranging teams aimed at the Sea of Rains, fired into that patch of uncertainty, and heard nothing come home. One of the sharpest lunar laser ranging efforts in the world, a group running a 3.5-meter telescope at Apache Point Observatory in New Mexico, tried and tried. Nothing. The working assumption in the field hardened into something close to a verdict. The first Lunokhod reflector was, for practical purposes, lost. And even if it were somehow found, no one expected much, because these mirrors were decades old now, exposed to the raw grind of lunar vacuum, and the whole field knew the reflectors up there were slowly getting worse, returning less light as the decades passed. A mirror lost for 40 years, if it turned up at all, would surely be a faint, degraded, half-dead thing. That was the wall the whole field had run into, and what finally cracked it did not come from a laser, it came from a camera. In 2009, NASA put a spacecraft called the Lunar Reconnaissance Orbiter into a low path around the moon, carrying cameras sharp enough to make out objects only a couple of meters across. For the first time, you could photograph the old landing sites and actually see the hardware sitting on the surface. And in March of 2010, a researcher named Albert Abdrakhimov was working through those images when he found, on the floor of the Sea of Rains, the unmistakable shape of the Luna 17 lander. Near it sat the rover, and running between them, faint but clear, were the wheel tracks. The twin ruts Lunokhod had pressed into the dust as it drove, there after 4 decades, curving away across the plain. So they followed the method, and I will keep it as plain as they did. First, the orbiter photographed the site and found the lander and the tracks. Second, those ruts led to the rover, and its position was fixed not to within several kilometers, but to within about 100 meters. Third, the team at Apache Point took those new coordinates, pointed the telescope, and fired. A corner reflector sends light straight back to its source, so the test was simple. Hit the right spot, and your own light comes back to you within a couple of seconds. It came home on the first night they tried. On the 22nd of April, 2010, physicist Tom Murphy and his team at the University of California, San Diego sent a pulse of laser light at the coordinates the orbiter had given them. And the mirror on the front of a machine that had been dead and lost since 1971 caught the beam and threw it straight back. Then they looked at how much light had returned, and this is where a simple recovery becomes something stranger. The signal was not faint. It was not the weak flicker of a degraded relic. It was one of the strongest returns anyone had ever gotten off the moon. On the very first attempt, they recorded about 2,000 photons coming back. To put that number where it belongs, the reflector's own twin on Lunokhod 2, the one they had been ranging successfully for years, gave back its best signals at around 750. The lost mirror, written off for 4 decades, was returning 4 to 5 times more light than the mirror nobody had lost. Let me stop here, because I want you to sit with the shape of that. For 40 years, this was the failure. This was the one they could not find, the blank spot on the map, the reflector the field had given up on, and when they finally hit it, it did not limp back to life. It answered louder and cleaner than almost anything else up there. The object everyone had written off as the weakest link turned out, the instant they found it, to be the best reflector on the moon. This is the part I find genuinely remarkable, and it goes beyond the strength of the signal. A mirror left in raw vacuum for 40 years, scoured by micrometeorite dust and swung between scorching and frozen twice a month, should have come back scratched and half dead, if it answered at all. This one came back almost pristine. That is why Murphy, when he first saw the numbers, said it could not possibly be it, but it was. It had been sitting out there, in full working order, the whole time, so the disappearance was over. The mirror was found, its position now known to within centimeters, and it went straight back into service as a target for the physics. For a moment, this looks like the cleanest possible ending. The lost thing was not merely recovered, it came back as the crown jewel. And the reflector turned out to be more than simply found. It sits closer to the edge of the moon's visible face than any other, out near the limb, which makes it especially good for tracking the slow wobble of the moon as it rocks on its axis, a measurement that feeds our understanding of what the moon is made of deep inside, and how gravity behaves across the gap between two worlds. The reflector on the second rover cannot be used at all when the sun is high over it. This one can. The 40-year-old abandoned machine, misplaced by a gap in the record, had handed the physicists a tool they did not have before. Now I want to be honest about what we do and do not actually know here, because this is the part the triumphant version of the story skips, and it is the part that matters most. Start with that word, cleaner. It is true that Lunokhod 1's reflector returns a strong, bright signal. It is also true, and this is not a contradiction so much as a deeper problem, that every reflector on the moon, this one included, is performing far worse than it physically should. When you work out how much light a perfect array up there ought to send back and compare it to what actually comes home, the mirrors are returning something like 10 times too little. And near the full moon, when the sun beats straight down on them, the signal collapses further, toward nothing at all. So the pristine mirror is only pristine next to its neighbors. Measured against the physics, it is faded too. Something up there is dimming these mirrors, all of them, and Lunokhod 1 is only the least dimmed of a set that has gone dull. What is doing it? The leading suspect is dust. The best current explanation is that a thin film of lunar dust has settled onto the glass faces over the decades, so fine and so slow that no one watched it happen, and that when the sun heats that dusty glass, the warmth distorts the mirror from the inside and smears the beam it sends back. That is the favored answer, and it was being argued out in the scientific literature as recently as a couple of years ago. Which means the honest map of this story looks like this. What we know, for certain, is that Lunokhod 1's reflector exists, that it was relocated in 2010 after 4 decades, and that it returns a strong signal now used for real physics. That part is solid. What we do not know is why. Nobody can say why this particular mirror outperforms its own identical twin by a factor of 4 or 5, when both were built to the same French design and both have sat in the same environment for about the same span of time, and nobody can say, with any confidence, what is dimming all of them. Dust is the leading idea, not a closed case, and between the two lies a wide territory of the suggested, the strongly supported, but not proven, the kind of answer a careful scientist offers with one eyebrow slightly raised. The finding solved a disappearance. It did not solve the mirror. If anything, catching that impossibly bright signal off the lost reflector opened a larger question than the one it closed. There is a second thing worth clearing up, because the moment this story got out, it grew a set of legends, and they are worth naming, so we can set them aside. When word spread that a Soviet machine, silent for 40 years, had been struck with a laser and answered, the retellings turned colorful fast, that it had somehow woken up or been switched back on. In the wilder corners, that it had never really been lost, that it had been hijacked, or moved, or taken. None of that is what happened. Nothing woke up. The rover is as dead as it was in 1971. A mirror does not need power, and does not switch on. It reflects, exactly as it did the day it arrived on the moon, and it had been reflecting into empty space the entire time, waiting for a beam to find it. There is a quieter correction underneath the loud one, and it is the one that actually matters. After the rediscovery, some of the engineers and scientists from the original program pointed out, reasonably, that they had never lost the rover. They knew, more or less, where they had left it. That is fair, and it locates the real disappearance correctly. The rover had not moved, and the people who built it still knew roughly where it sat. What had slipped away was the precise, published, usable set of coordinates that physicists everywhere else needed in order to aim. The gap was in the shared record. And I think that distinction is the true center of this whole story, the part almost every dramatic version of it gets backward. So here is where this leaves us. The deeper puzzle is not solved. The mirrors on the moon are returning far less light than they should. The dust explanation is still being worked out, and nobody can yet tell you why the lost reflector shines so much brighter than the one that was never lost. The moon goes on drifting away from us, just under 4 centimeters a year, indifferent to all of it. And the machine at the center of the story is exactly as dead as it was on that cold night in 1971. It gave 10.5 kilometers and 11 lunar days, and then it went dark, and it is never going to drive again. But the mirror on its front is arguably the single most valuable object of its kind on the entire moon. The deeper lesson here, I think, is about that word, lost, and how much of it is usually about us rather than about the thing. Lunokhod 1 was never hiding. It sat in the open on a plain with no weather, unbroken, doing its one job, patiently throwing back into the dark whatever light happened to reach it, for 4 decades. The machine had done nothing wrong. What failed was our record of it. A number taken and never shared, a coordinate that slipped through the seams of history, and when we finally decided to look properly, almost nothing was needed to close the gap. It took a camera in orbit, a set of wheel tracks in the dust, and a single pulse of light. This is not a story about a machine that came back to life, because it did not, and it never will. Lunokhod 1 is a dead rover on a dead sea, but it is a story about how a thing can be sitting in plain sight, unbroken and working, and still be completely lost, only because nobody knew precisely where to look, and about how little it can take, in the end, to find what was never really gone. So picture it now, out there on the Sea of Rains, exactly where it stopped. The 8 wheels settled a little into the gray dust, the 2 ruts of its last drive curving away behind it, as sharp as the day they were pressed, because nothing on the moon has touched them since. The lid closed for the last time over instruments that went cold half a century ago, and on the front of it, angled down toward a bright blue point of light in a black sky, a small French mirror catching a faint green pulse from a mountaintop in New Mexico a few nights a year and throwing it straight back home, still answering. And half a century on, almost exactly as it was the day it landed. If this is the kind of story that pulls at you, the machines we abandoned and forgot and then stumbled back into, stay close, because the history of spaceflight is full of them, half lost and stranger than the headlines ever let on. There are far more of these out there than you would ever guess.